My internship is located at the Chemical and Biomolecular Engineering and Chemistry building at The Ohio State University. Every day, I take the CABS bus to get there, either from my OSU French class or from Metro High School. The research lab that I worked at, the Cowan Group, is located on the third floor of the building. I worked around 2.5 hours each day in the mornings from Tuesday through Friday. This is the lab that I worked at throughout the entire semester. I worked at different areas in the lab, depending on who I was helping or what instrument I was using.
My name is James Cowan. I'm a professor in the Department of Chemistry and Biochemistry. I hold the Melvin S. Newman Chair in Chemistry, and also I am a Distinguished University Professor. And my labs in the department are focused in the area of bioinorganic chemistry, which is the broad area of a research interest. We have a few major research themes in the lab. One involves understanding the cellular chemistry of iron. Iron is an important element, it's an essential element. Another major theme in the lab is in the understanding development of catalytic metallodrugs. So these would be therapeutic molecules that incorporate metals. And from that area also stems our third major interest, which is in catalysis, trying to design molecules that mediate chemistry in a variety of ways that are easier, can occur at room temperature, more gentle conditions. And we're particularly interested now in developing catalysts that promote the degradation of sugar molecules.
So I'm Zach. I'm a first year graduate student here in the department. I joined the lab in early spring semester.
I'm Jessica Alexander. I'm at the end of my 5th year in the department, so hopefully I'll be graduating next year. And yeah, Zach and I work on similar projects.
So how do I contribute to the ongoing work with your research project?
Okay, so essentially one of my projects is the detection and the breakdown of sugars, and you helped me make one of the 4 catalysts that I'm working with. So you helped me with a little bit of organic synthesis. You also helped me try to determine some of the kinetic parameters, so how fast the reaction was going, essentially how specific the reaction was for a particular substrate. So say you had 3 things and you want your catalyst to recognize 1. You helped me figure out that for one of the catalysts. One of the big things is also molecular recognition. So you tested glucose's solubility in different solvents to try to freeze out some of the conformational movements that glucose takes. So you helped me out with that.
Okay, so the main project that you helped me out with were these antimicrobial peptides. So these are short peptide sequences that are produced by the innate immune system of virtually all species, and there have been hundreds that have been identified. So I have 13 of these peptides, each of which contain a metal binding domain, so they're able to do redox chemistry on various biomolecules. And so you've been helping me determine what biomolecules they can bind to and if they can cleave those biomolecules. Specifically, you've helped me set up peptide synthesis to make a couple of my peptides. I know you ran the ATP co-precipitation assay to determine that the peptides can bind ATP, as well as the ATP phosphate assay, and an assay in which we monitor ATP cleavage by HPLC. And then you've also helped set up lipid peroxidation assays to determine if they can oxidize lipids as well.
So Jessica also mentioned HPLC. That was the other thing that you helped me with to separate out the compounds. So HPLC is essentially the high pressure liquid chromatography. So it's a technique that allows us to separate the different compounds out and get actual very pure things, essentially.
Yeah.
Okay, great.
This is the UV-Vis. It's an instrument that I worked a lot with. It stands for ultraviolet visible spectroscopy, and it's used for kinetic analysis. Basically, the UV-Vis monitors a substance's absorption wavelength over time to understand its kinetic parameters. I use this instrument for one of the catalysts in Zach's project, as well as Jessica's ATP phosphate assay. So this graph is an example of data collected from the UV-Vis. This is the HPLC. It stands for High Performance Liquid Chromatography. The HPLC separates compounds using different solvent systems by pumping a sample at a high pressure through a column. I use this for Jessica's ATP cleavage. The mass spectrometer is an instrument that allows us to detect what's in a sample. So, we basically inject the sample into the instrument where it becomes ionized. It then travels through a voltage difference and becomes charged, allowing us to figure out the mass of the particles and what's actually in the protein or molecule. Unlike the UV-Vis, the plate reader allows us to test 96 different samples at once, so we use a 96 well plate to put our samples in. Jessica and I use this instrument for the ATP co-precipitation assay. This is the peptide synthesizer, and it's really valuable in the lab because it makes the peptides, so we don't have to make them by hand. Basically, we just have to weigh out the amino acids and reagents we need and program the synthesizer so that it makes the peptides. This instrument, called the autoclave, uses steam under pressure to sterilize media and containers. Basically, we pack everything we want to sterilize and put them in boxes, and we put a piece of tape on top. Once black stripes appear on the tape, we know that it's done autoclaving. I had to use various metro habits to be successful in the lab. I definitely had to be an inquiring learner, since a lot of the experiments and research done in the lab dealt with higher level concepts that I didn't have exposure to. I had to constantly ask questions when I didn't understand something. That goes hand in hand with being an engaged learner. Since I worked in a lab, I often got hands-on experience with different lab skills, allowing me to learn in a more interactive environment. I also had to be an effective collaborator. Even though I worked with Jessica and Zach the most, I did shadow and help other graduate students in the lab sometimes, and working on projects with them allowed me to become a better collaborator overall. I also needed to be a critical thinker. With the little background I had in biology and chemistry, I needed to constantly be thinking about the topics and make sure I grasped the concepts in the experiments.
So, how did you feel about my overall performance this semester?
Overall, I was very impressed by your performance, especially considering that you had very little background in biology or chemistry. So there is a large learning curve, and obviously, given the amount of time, you're not going to understand things fully or as deeply as we do. I think that's not reasonable to expect of you. But I was really impressed by the amount of enthusiasm that you had every day, and the fact that I think the biggest thing is that you were genuinely interested in what we were doing and genuinely interested in learning why we were doing the things that we were doing and what was going on. Do you want to add to that, Zach?
Yeah, no, Swati, she exceeded all of my expectations when she came in.
Especially for a high schooler,
For a high
because
school student, yeah.
I think there are a lot of undergraduate students on this campus, I think, who would not be able to perform quite at that level.
Exactly, and with only having essentially high school chemistry and some of the more high school classes and not the college level classes, Swati did very, very well. You did awesome. And you were very enthusiastic, like at all times. It was
Yeah.
great. It was actually refreshing to see that.
Very refreshing.
Yeah, no, she was awesome.
You should do undergraduate research when you go into college.
Yes, for sure.
Go to Ohio State, come join our lab.
Yeah. For sure.
So I think she's had a productive few months, has learned a lot, has participated a lot in the development of these two projects, and hopefully some of these things will help her in the years ahead, or at least give her a broader idea of what research in the chemical and biochemical sciences can involve. So it was good to have her, and we wish her well in the years ahead.
Overall, I would say my experience was extremely positive and successful. I loved the environment and atmosphere of the lab. Everyone was extremely welcoming, and I felt like I truly belonged at the lab for the time that I was there. I was amazed by the amount of trust that Jessica and Zach placed in me. They gave me the freedom to learn and showed me that failure is common when it comes to research and experiments. My advice to future interns is to always be open to new opportunities. Don't turn away from an internship just because it wasn't what you were initially interested in. There's always a chance that your experience turns out to be better than you imagined. I got a sense of what research is truly like, and this experience has completely changed my perspective about research. I hadn't realized how much time and effort is spent in the lab working when it comes to research. This experience provided insight on my own career choices, allowing me to realize that I really liked working on projects in the lab. Overall, this internship was extremely invaluable. Whether it was the skills I learned or the people I met, I will truly cherish the time I spent at this research lab. I made amazing friends in the form of mentors that I will always look up to and admire.